MCQ type problem from the previous year paper of recruitment of wbpsc assistant master recruitment. Okay, the problem number 5. The vertex of the parabola whose axis is parallel to y-axis and which passes through 3 points are given. We have to find the vertex. Okay, so the parabola is of the type this. Okay, that is the axis is parallel to y-axis, and we write directly equation of parabola whose axis is parallel to y-axis is given by y, this is equal to ax square plus bx plus c, and since it passes through 0 4, so we get this is given by 4 equal to c from the first point. By putting the second point, we get this is 1, this is a minus b plus 4, so we get a minus b, this is equal to minus 3. Okay, and by putting the last point, we get minus 4, this is equal to 4a minus 2b plus 4, and this gives 4a minus 2b, this is minus 8, so 2a minus b, this is minus 4. Okay, now subtracting this and this, we get this is plus, this is minus, this is plus, and getting the result as minus a, this is equal to 1. Get a, this is equal to minus 1, and by putting the value of a here, we get this is minus b, this is equal to minus 2, so b equal to 2. Now we put the value of a, b and c in this relation. We get the relation y, this is equal to minus x square plus 2x plus 4. Okay, so we get minus x square minus 2x plus 1 we get, and we here add plus 1 plus 4, so y minus 5, this is equal to minus of x minus 1 whole square, and the equation of parabola x minus 1 whole square, this is equal to minus y minus 5, right? So the vertex is at alpha beta, which is given by 1 comma 5. Okay, this is the vertex of the parabola, but in our option 1 comma 5 is not belongs to our given option, so I go for the option number A, because here 3 comma 5, I think this is 1 comma 5 maybe. Okay, and now the second problem, the general solution of dy dx, this is equal to e to the power x minus y into e to the power x minus e to the power y. So we write the equation dy dx, this is equal to e to the power, multiply this e to the power 2x minus y minus e to the power x, because e to the power minus y and e to the power y cancel out. Now we write the equation in the form dy dx plus e to the power x, this is e to the power 2x by e to the power y, and we get e to the power y dy dx plus e to the power y e to the power x, this is e to the power 2x. Here we put e to the power y, this is equal to z, and we get e to the power y dy dx, this is dz dx, right? So we get the linear form dz dx plus z into e to the power x, this is equal to e to the power 2x, and integrating factor is equal to e to the power integration p dx. Here e to the power integration p means e to the power x, so e to the power x dx, that is e to the power x. Now multiplying by the integrating factor, we get the solution as z into e to the power x. This is equal to integration e to the power 2x into e to the power x dx plus c, integrating constant. Now here we put e to the power x, this is equal to p, So we get e to the power p dp. This is e to the power, this is e to the power x dx. This is dp. Okay, and the integration in the right hand side is given by p e to the power p dp plus c, and the integration of this function by integration by parts, we get this is p minus 1 into e to the power p plus c. Right, now putting the value of z here, z means e to the power y, so we get e to the power y into e to the power x, and putting the value of t, which is given by e to the power x, so we get the solution as e to the power y. This is equal to e to the power x minus 1 into e to the power p, means e to the power x, and e to the power x cancel out, so the last term is c into e to the power minus e to the power x. Okay, this is the final solution of the ODE. So our correct option is option number A. So option A here correct, I think, and here also option A correct. Okay, these two are very interesting and easy problem of MCQ type. This is from geometry and this is from ODE. Thank you for watching.